Hello and welcome to Byju's JEE. My name is Mrinal, and in today's session we are going to discuss the physics segment of JEE main paper, which was conducted on 7th of January in the morning shift. So if I talk about this paper, it was a pretty balanced paper and questions were asked from all the segments as such. Let's do a quick analysis first. So if I talk about mechanics, 6 questions were asked from mechanics. Thermo and KTG had 4 questions. Waves and oscillations had 2 questions, and electromagnetism had 7 questions, whereas optics and modern physics, both of them had 3 questions each. Now overall, if I talk about the difficulty level of this paper, it was from easy to moderate. However, there were some questions which required some advanced thinking skills and they were slightly difficult. You will find that out when we are solving the problems in this session. As I solve the problems, I'll also tell you which chapters were touched upon, which concepts were asked, and what was the difficulty of each individual problem. So with that, let's start by solving the problems. Now let's look at this question from wave optics. Now this is a question which is based on polarization of light. And if you ask me the difficulty level of this question, I would say that this is a moderate type of question. So let's understand what is given in this problem. So in this problem, you have an analyzer polarizer setup, and it is told that when you pass light through the first polarizer, which is inclined at some angle phi, okay? Now the intensity of the light that comes out is equal to, well, 1/10 of the initial intensity. Fine. Let's say initially the intensity was I naught. So what comes out after passing it through the first polarizer is I naught by 10. Fine. Then it is asked that by what angle you are supposed to rotate or place another polarizer as such, so that the intensity of the light which is coming out from this is going to be equal to 0, right? Now we know one thing for sure, that if you don't need any light to be coming out from the polarizer, the angle between the plane polarized light, or the axis of the plane polarized light, and that of the polarizer has to be at 90 degrees, right? So we have to find this angle by what angle you are going to basically rotate this polarizer, right? So let's do this. So it's given that you are tilting this by an angle of phi. Initially the value was I naught, the value of intensity when it was just polarized light, plane polarized light as such. And once it comes out, the intensity becomes I naught by 10, right? Now here we are going to use the Malice's law, and it says that I equals to I naught times cos square phi. Now we know that the value of I in this case, after you have placed the first polarizer at an angle of phi, is equal to I naught by 10. So if I plug that in, I get I naught by 10 equals to I naught cos square phi. So I can cancel off I naught, and from here we get cos phi is equal to 1 by root 10, which is approximately equal to 0.3 I can take, right? Now understand this, the value that we have got is 0.3, right? And then we have to rotate it, or you can place another polarizer as well, but this has to be perpendicular to the plane of polarized, the axis of the plane polarized light as such, right? So once you do that, well, the angle by which you must have rotated it or you have placed it should be equal to 90 minus phi, and 90 minus phi is what we require. Now if you look at the options over here, well, these are all different options, and only 2 of the values is what I know, right? So I need to take a guess. How do we guess this? So you have got this value of cos phi as 1 by root 10, which is equal to 0.3. Think about cos of 45, that's 1 by root 2, which is equal to 0.7. Now clearly the value of cos 45 is greater than the value of cos phi in this case, right? Once you realize that, you have to understand that this value phi must be greater than 45, correct? So if phi is greater than 45, phi is greater than 45 degrees, since cos phi or cos theta is a decreasing function, as you go on increasing the value of theta, the value of cos theta goes on decreasing, correct? By using that logic, we understand that 90 minus 5, this value has to be definitely less than 45 degrees. So if that is going to be less than 45 degrees, we have got only one option, that is 18.4 degrees, and that is the correct answer to this question. Now this question was from Gravitation, and specifically talking, it was from the concept of orbital velocity. And if I talk about well, whether it was easy, medium or hard, well, I will place it as one of the difficult questions that was asked in this particular exam. So let's get to the problem. So in this problem, it was told that on the surface of the Earth there is a satellite, and this satellite is launched in a vertically upward direction. Once it reaches to a height equal to the radius of the Earth, then a rocket is fired off. The mass of this rocket is m/10, and this satellite starts orbiting the Earth. We have to find out the value of the kinetic energy of this rocket. So let's understand this. Let's first see the initial situation. So this is the Earth, and then we place the satellite. The radius is r and the mass is m, and then we write the expression of initial energy. So initial energy, of course, is going to be kinetic energy plus the gravitational potential energy. Right over here you can see the expression of kinetic energy, and here is your expression of potential energy when this satellite was launched with an initial speed of u in vertically upward direction as such. Now once this is launched and it reaches to the orbit, then we can write the total energy at this point. Let's say the velocity it has is some value v. That point the kinetic energy will be half m times of v square plus the potential energy will be minus g mass of the Earth times mass of the satellite divided by 2r. Why 2r? Because now if you see, the distance is 2 times of r, right? Now with this expression, by conservation of energy, you are going to get the value of v as such. So this expression gives you the value of v, and once you have got that, then probably we have to understand what happens after this. At this point a rocket is fired off, and as you fire the rocket, the mass of the satellite which is remnant is m/10, 9m/10, and the mass of this rocket is m/10. 1/10 of the mass is flies off, right, with some velocity v. Then what happens is this satellite starts orbiting the Earth, and then you have the expression of orbital velocity with the mass of the satellite as a 9m/10, and you get this VO equals to root over of gme upon 2r. This is just the normal formula of the orbital velocity as such. And if you talk about the mass of the rocket, well, mass of the rocket is m/10, and it is going to have some velocity, but this velocity can be broken down into two components. One can be broken down to radial direction and the next one in tangential direction. So then you have to apply the law of conservation of momentum, and once you apply law of conservation of momentum, I can say the momentum before rejection must be equal to momentum after it. And once you do that, let's first do it in radial direction. So in radial direction I can write initially as mv, and final is m/10 times of vr, right? And if I talk about the value of VR, the value of V we have already found out, right? So once you plug them in, you're going to get the value of VR equals to 10, and in root over you'll get u square minus gme upon r. So this is the expression that you get. Then let's talk about the tangential direction. If I talk about the tangential direction, well, initial velocity was 0, right? So initial momentum will be 0, and finally you'll get m/10 times vt minus 9m/10 times VO, right, by conservation of momentum, of course. And then you need to get this value of Vt, which is the tangential component of the velocity, and that comes out beautifully as 9 root over of gme upon 2r. Once we are done with this, we are almost done. All you have to do is figure out the expression of kinetic energy, and kinetic energy is going to be equal to half m/10, which is the mass of this rocket, times Vt square plus Vr square. all you have to do now is plug in the value of Vt and Vr that we have already found out and square them up, add them up and express the kinetic energy term. And if you do that, well, you end up getting this expression as your final answer. Now if I talk about this problem, it is from the topic of current electricity. More specifically, it comes from the subtopic of combination of resistances in series and parallel. Well, if I have to rate this problem in terms of difficulty level, I would rate this as, well, easy, I would say. So let's look at this problem. So in this question, you have been asked the value of current which is flowing through one of these 1 ohm resistances. Now to find the value of current flowing through these one of the 1 ohm resistances, what we'll first need is the net current which is flowing out of this battery, right? So first of all, we need to solve the circuit, get the effective resistance of the circuit and then use the Ohm's law. From there we are going to get the value of I, and then probably we'll again use Ohm's law for one of those branches and then find out the current which is flowing through this specifically 1 ohm resistances. So that's going to be our path as far as this question goes. So if you see these two resistances 1 ohm and 1 ohm are in parallel combination. Now if I use the formula of R effective in terms of two resistances, I can use it as R1 times R2 divided by R1 plus R2. Well, I get an effective resistance of 1 by 2 ohms, right? Now if you see, this resistance and this 2 ohm resistance are in series, right? If I have to combine them, well, they come up to be 5 by 2 ohms, and then this resistance and this are in parallel combination. Again, I'm going to use the formula of parallel combination, and R effective for this entire circuit you are going to get as 10 by 9 ohms. Now once you have reached up to this point, well, you have to find the value of current. So you know Ohm's law, which is V is equal to I times of R. Obviously I is going to be equal to V by R. So in this case V is 1 and R we have found out to be 10 by 9. So this will be equal to, well, 9 by 10. So these many amperes, I mean the value of current is going to be, I is going to be 9 by 10 amperes for the entire circuit as such, the current which is flowing out of the battery, right? But we are not supposed to find the value of the net current which is flowing out. Rather, we were supposed to find the value of the current which was flowing through one of the 1 ohm resistance, right? As you notice that this current I is going to break into two parts. Let's say I1 and let's say this is I2. And if you remember, within this branch only there was 1 ohm resistance. So I need to find the value of 1 ohm resistance. Also, if you notice that the potential difference across these 2 points in the circuit and these 2 points in the circuit are going to be equal, right? So they are connected in parallel combination as such. If that is true, then I can say that the value of I2 is going to be equal to, for this branch the effective resistance is 5 by 2 and the potential difference is 1 volt. So 1 divided by 5 by 2, that gives me, well, 2 by 5. That's the value of current. So I2 is equal to 2 by 5 amperes. Now that we have found out the value of current that is flowing through that branch, yes, all we have to do is divide this current into two parts, because this current, which was 2 by 5 amperes, gets divided into this as well as this. So through one of the branches, as in 1 ohm resistance, how much current will be flowing? That will be just 2 by 5 times 1 by 2. And what do you get? Well, that's equal to 2 by 10 amperes. So the current which is flowing through both of these 1 ohm resistors, you can say, is equal to 2 by 10 amperes, and that is the correct answer to your problem. Now this question is from semiconductors, specifically from logic gates. Well, if I have to talk about the difficulty level of this problem, I'll say, well, it's an easy question. So let's look at this problem. So in this question, you have been given with 4 logic gates and we have been asked that which of these logic gates are reversible. Now the first thing that you have to understand is what is a reversible gate. A reversible gate is one where you can retrace the input uniquely just by looking at the output. Now the only reversible gate which we have is the NOT gate. So this entire question in a different way is asking us to find out which of these logic gates can be represented as a NOT gate. We know that the only option for us is to use this NOR gate as such. So now if you just take this gate and if you feed the input as 1, well, what you're going to get as output, you're going to get as 0, right? So you feed 1 and you get 0. So this is the correct answer to this problem. This question is from center of mass, specifically talking about this problem. It is from the center of mass of discrete particles. Well, if I have to rate it, I would say that this is more of a easy type of problem. Okay, so let's see what is given in the problem. So you have got 3 particles and their coordinates are given to us, and we have to find the value of center of mass of the system as such. So how do we do this? You know, the formula for center of mass, x coordinate, I can write as m1x1 plus m2x2 plus m3x3 divided by m1 plus m2 plus m3, and similarly I'll have a formula for y coordinate of center of mass that's going to be equal to, well, m1y1 plus m2y2 plus m3y3 divided by m1 plus m2 plus m3. So all we have to do is you have to plug in the value of all these masses and their position as such in terms of x and y, and get the x coordinate and y coordinate of center of mass. This is a pretty straightforward problem, so let's just solve this. So if I talk about the x coordinate, I can write for x coordinate of center of mass is going to be equal to, well, for this mass of 2.5 kg the x coordinate is 0, so I won't have to care about it. Well, even for this 1 kg it's 0, so I have only 1.5 times 3 divided by the total mass. The total mass is, well, 4 plus 1, that's 5. So you get the value as 0.9. And as far as y coordinate of center of mass is concerned, we'll have this, for this 1.5 kg the y coordinate is 0, so we are not going to calculate for that. And for this 1 kg also y coordinate is 0, so we are left with only with this 2.5 kg, so we'll have 2.5 times 4 divided by the total mass of the system, that's 5. So, well, you get a value of 2. So these are the values of the coordinate of center of mass, and that is the answer to this problem. Now this is a question of wave optics. If I have to specifically mention the subtopic, it is from diffraction. Okay. Now this particular problem is an easy one, I would say. So this is what our meter shows actually. Now in this problem we have been told that the second minimum is obtained when the angle theta is equal to 60 degree. We have to find the value of theta where you'll obtain the first minimum. Okay. So the general expression for minima is d sine theta is equal to n lambda. And if I use the conditions given in the problem, what do I have? We have d sine of 60 degrees is equal to 2 times of lambda, right? Right. Let's say that I obtain at some angle theta my first minima, so this will be equal to d sine theta is equal to lambda, right? So these are my two equations. If I divide them, what do we get? Well, d gets cancelled out and this lambda gets cancelled out. Sine 60 is root 3 by 2. So if you rearrange, you end up getting value of sine theta equals to root 3 by 4, and that is equal to, well, 0.43. Now I know my value of sine of 30 degrees, that is equal to 1 by 2 or 0.5. So the value which matches nearest to my answer has to be less than sine of 30 degree or 30 degree as such in terms of angle. So the correct option which matches is 25 degrees, and that is the answer to this problem. Now this question is based on alternating current and oscillations. So in this problem we have to do a comparison basically, right? The sub-concepts involved are LCR circuits and SHM. Now if I talk in terms of the difficulty meter, well, I'll say that it's more towards the medium size. It's not very easy, but yeah, it's almost like a medium level question you can expect. So in this problem we have been told to compare two systems. One is a simple physical spring and mass system, it's damped of course, and the second system is the LCR circuit, and we have to have a comparison between the two. So let's look at it one by one. So first of all is the spring mass system. Spring mass. Okay, so this is a physical system, and if I have to write the expression of force, well, it looks like this. F is equal to minus kx, but this is not just a non-damping force as such. It also has a damping constant, which means I need to add one more term, that's minus p times of v, right? This is the expression I get. Now I need to express this in terms of a differential equation. So force can be written as mass times of acceleration, and acceleration is nothing but double differentiation of the displacement. So I'll write it as d square x by dt square is equal to minus, we have kx minus b, and v can be written as dx by dt. So this is dx by dt. Now let me just express this in differential form or in form of differential equation. So I'll get m d square x by dt square plus b dx by dt plus kx, and this is equal to 0. Right, so this is what we get for a spring mass physical system. Now what about the LCR circuit? So for LCR circuit we can write, well, the expression for an entire loop of voltage, we have L di by dt plus we'll have IR for resistance plus Q by C for the capacitance, and this is equal to 0, right? Let's again express this in terms of differential equation and express everything as a differential of dq. So I can get L di by dt can be written as d square q by dt square plus I can be written as dq by dt times R, and q by c remains as it is. Now if you try comparing both of these expressions, you'll notice that, well, m corresponds to this value of L, you have R corresponding to this damping constant which is equal to B in this case, and you have got the value of K as equivalent to 1 by C, and that is the answer to your problem. Now this is a question on rotational dynamics. Specifically, I would say that if you plan to solve this problem, you can solve it in two different ways. You can either use work energy theorem or you can use angular acceleration. Well, we'll also use some concept of moment of inertia as well. Now, if I have to rate this problem, I would say this is an easy kind of a problem. Well, so let's understand what is going on in this question. So you have a block of mass small m, and it is connected to a light inextensible string, and then it is wrapped around a disk of the same mass. Alright. Now this mass is allowed to fall down under gravity, and as it falls down, this disk will start rotating with some value of omega. We have to find this value of omega. That is what the question is asking. Right. Now if we allow this mass to fall down and this disk starts rotating as such, we'll say that, let's say that this has fallen to some value h. What we can assess from here is that the change in potential energy, or rather the decrease in potential energy, is going to be mgh for the system, and this decrease in potential energy will be equal to, well, the gain in kinetic energy. So at this point, let's say this block is having some value of velocity v. Okay, we can say this is equal to half mv square, which is the kinetic energy of this block, plus, since this disk is rotating, it will have rotational kinetic energy, and that is going to be plus half I omega squared, right? Now we have to take one or two assumptions over here to solve it further. First thing is that we'll say that at all times the string remains taut, okay? And the second assumption is that we'll say that the string is not slipping over the disk, which means I can have this expression of V is equal to R times omega, where R is the radius of this disk. Fine. Now, all you have to do is just write down the value of moment of inertia of this disk. So half mv squared plus, well, the value of moment of inertia is going to be equal to mr squared by 2. So mr squared by 2. We also have a half over here, and then, well, omega squared. This is what we have. Let me write the kinetic energy separately for you. So this plus the rotational kinetic energy is going to be half, and I value is mr squared by 2 times omega squared. Now all you have to do is substitute V is equal to R omega, get the value of omega, and if you do that, you end up getting the value of omega equals to 2 upon R root over of GH by 3, and that's the answer to your problem. Now the next question is from modern physics. Specifically, it is from atomic structure as such. So if you talk about this problem, well, this ranges from easy to medium on this difficulty meter. That is what it shows, right? So in this question, we have been told that the time period for an electron in hydrogen atom or the ground state has been given to us, and we have to find the value of frequency when this electron is in first excited state, okay? So the time period for the ground state, that is T1, is given as 1.6 to 10 to the power of minus 16 seconds, right? And we have to find the frequency for this first excited state. Definitely, we have the value of N1 is equal to 1 and N2 is equal to 2. For first excited state, the value of N is 2. And the relation between T and N, we have T is directly proportional to N cubed upon Z. Now in this case, since it is a hydrogen atom, the value of Z is equal to 1. So T becomes directly proportional to N cubed. So I can write T1 by T2 is equal to N1 by N2, and I can just cube this, right? So I can write, well, T1 was equal to 1.6 into 10 to the power of minus 16 and divided by T2, and this is going to be equal to, N1 value is 1 and N2 is 2, so cube of that is going to be equal to 1 by 8. And if you just rearrange this, you are going to get the value of T2, right? But we are not supposed to find T2 over here. We are supposed to find the value of F2, right? So F2 is nothing but 1 by T2. All you have to do is rearrange this, and you end up getting the value of F2 equals to 7.81 into 10 to the power of 14 Hertz. And that is the answer to this question. So now this is a question which has got two concepts basically, or two chapters are involved. One is the wave and other one is the mechanical properties of solids. So if I talk about the exact concepts, well, it has got concepts of transverse wave and stress strain relationship, okay? And if I talk about the difficulty level for this problem, this is a moderate type of question. So let's see what is given in the problem. So we have been given the mass of a steel wire, we have been given the length, the area, the velocity, and the value of the Young's modulus. It's also told that this is a transverse wave on a steel straight wire, okay? So if I have to find the value of increase in length or extension, we have to get delta L. Now how do I approach to the value of delta L with all these informations given? First thing is, we have to express the value of tension, right? So tension is equal to Well, mu times of v square, where mu is nothing but mass per unit length. So I can write it as m by L times v square. And if I talk about the Young's modulus, which is also mentioned in the problem, I can write Young's modulus is equal to stress by strain. So Y will be equal to, in this case, stress is going to be tension by area, right? So we'll get T by A and we'll have L by delta L, right? Because strain is basically nothing but L by delta L, and if you just do that, you're going to get this expression. Now all we have to do is take this value of T and substitute in this particular expression, right? Let's see what we get. So we have Young's modulus is equal to T, which is m by L times v square, times L by A times of delta L, right? So this L and this L gets cancelled out. So we are left with delta L can be expressed as mv square divided by A times Young's modulus. Now all these values are given in the problem itself, but the thing is that all these are in different units. So you just use a standard unit, and once you convert and just plug them in, you're going to get the value as 0.3 mm, and that is the answer to this question. Now this next question is from Newton's law, and if I talk about the concept that are involved in this problem is, well, we have friction and power. And if I talk about on a difficulty scale, this question seems to be easy, right? So in this problem, we have been given that there is an electric motor which has a capacity of or power of 60 HP horsepower as such, and you have the conversion over here. Now this is used to move a lift in upward direction, but there is also frictional force, and we have a maximum mass capacity for this lift, which is given as 2000 kilogram, right? So we need to find the value of the speed by which this motor will be able to move the lift when it's at full capacity. All right, so let's first think about it. If the lift is moving upwards with some velocity, let's say v, what are the forces it has to overcome? Well, it has to overcome, first of all, this frictional force, and it also has to overcome the weight, which is, well, 2000 times g, which is mg, right? So I'll just show you here. So this is the frictional force, plus it has to overcome the weight, that is mg, right? So let's first calculate that. So we have got the value of mg, the mass in maximum load capacity is 2000. So 2000 times 10 plus we have got 4000 as the friction force. So this comes out to be 24,000 newtons, right? So this is the force that it is able to overcome by using this motor as such. So I can write power is equal to force times velocity. In this case, it is the force it is able to overcome, which is equal to 24,000 newtons, and we have the value of power over it. It's 60 HP, and 1 HP is equal to 746 watts. So let's just convert it. So power is equal to 60 times of 746, which is equal to, well, 24,000 times velocity v, and this is the value of v is what we have to find out. Now if you calculate, you're going to get v equals to 1.9 meters per second, and that is the answer to this question. Now this is a question from kinetic theory of gases, specifically, well, from mixture of the gases. And if I talk about the difficulty level, well, this question can be treated as a moderate type of question. Okay, so let's directly dive into the problem and see what is being asked. So in this question, we have been given that there are two ideal gases and both of them mix, Okay, the number of moles for both of these gases are given. We have also been provided with the value of Cp and Cv, which means the value of gamma for both of these gases are given, right? We have to find the value of gamma of the mixture. So first thing what we have to do is find the value of Cp and Cv for both of these individual gases as such. For that, we are going to use this formula, which is Cp is equal to R gamma divided by gamma minus 1. And if you do that, you end up getting the value of Cp for the first gas, that is equal to, well, Cp is equal to 5 by 2 times of R. And by using this formula of Cv, when you calculate the Cv for the first gas, you're going to get the value of Cv equals to 3 by 2 times of R. Now, once you have calculated this, you should also calculate the Cp and Cv of the second gas as well. So let me write this as Cp1, let me write this as Cv1, okay, since it is for the first gas. Similarly, by using these two formulas, if you calculate Cp and Cv for the second gas, you're going to get, well, Cp2 is equal to 4 times of R, and Cv2 you're going to get equal to 3 times of R. This is what you get, right? Now you need to get the value of gamma of the mixture. So gamma of the mixture is equal to Cp of the mixture divided by Cv of the mixture. And this can be written as N1 Cp1 plus N2 Cp2 divided by, well, N1 Cv1 plus N2 Cv2, right? And here you have all the values, everything is given. And once you calculate this, you get the value of gamma of this mixture equals to 1.42. And that is the correct answer to this question. Now this is a question from rotational dynamics, more specifically from the concept of moment of inertia. And if I talk about the difficulty level of this problem, well, you can term that as an easy problem as such. So let's look at this question. So this question says that we have to find the value of radius of gyration of a rod about an axis which is at a distance of L by 4 from its center. So let's mark this axis as y dash. We know the formula of a radius of gyration, which is equal to mk square. So moment of inertia about y dash is going to be equal to mk square, where m is the mass of the rod and k is the radius of gyration, right? So if I have to find the value of moment of inertia about y dash axis, so how do we do that? First thing is that we have to use the parallel axis theorem. So I can write I about y dash is equal to ml square by 12 plus we have m times L by 4 whole square, right? And this gives me a value of 7 by 48 times of ml square. And this value of moment of inertia about this axis of y dash, I have to equate it to this value of mk square, right? So let's do that. So we have got 7 by 48 ml square is equal to mk square. Well, I can cancel off this m and m, and we get the value of k equals to L root over of 7 by 48. And that's the answer to this question. This is a question from electromagnetism, specifically from solenoids. Okay, so the induced EMF in solenoid is the concept which is involved, and this was one of the questions that I really felt was slightly difficult, I would say. Okay, so now let's see what this question was. So in this problem, you had a solenoid and there was a time varying current for the solenoid as such. And then what you did is you placed a coaxial ring in the center. The radius of the solenoid was R and the radius of the ring that you have placed was equal to 2R. Fine. So we need to figure out the value when the current actually reverses its direction. Fine. So now if I think about it and if I need to write the value, I can say first of all flux phi is equal to B dot A, right? If phi equals to B dot A, then what we can say is I can write the value of B as mu naught times N times I, and area. What do I take the area? Should I take the area of the solenoid or should I take the area of the ring? Here is where the confusion arises, right? So you need to take the area of the solenoid only, not the ring. Why it is so? Because outside the magnetic field will be 0. And we eventually have to find out the value of EMF when it becomes equal to 0. Because only when this EMF will be equal to 0, at that point, the current is going to reverse the direction, right? So the area should be pi r squared, right? Don't make a mistake of writing it as 2r. So now I can write the value of the EMF as d phi by dt, and I have the value of the current. So first of all, let's write the full expression of flux. So mu naught times N times I is nothing but I naught times T, 1 minus T, and we have pi r squared, right? This is what we have as the expression for flux. So we know that d phi by dt is equal to, or minus of d phi by dt is equal to EMF, right? This comes from Faraday's law. So if you find that out, we'll get EMF is equal to, you have to just differentiate this expression and you get mu naught times N times I naught and pi r square. All these will be constant and you get a value of 2t minus 1 on differentiating this with respect to time, right? Now at which point will this EMF will be 0? When this EMF has to be 0, this factor, that is 2t minus 1, has to be 0 because rest all other things are constant, right? So if I write 2t minus 1 equals to 0, then I get t equals to 1 by 2 seconds, which is nothing but 0.5 seconds, and that is the answer to this question. Now let's look at this problem from electrostats. Okay, specifically if I say, well, this question is from variable capacitance, and then if you ask me, this was one of the toughest problem as far as this paper is concerned. So even if you measure it on this difficulty meter, you'll get it as very difficult as such. Okay, so let's quickly understand what is asked in the problem and solve it. So in this case, you have a capacitor and it is filled with a dielectric, but the dielectric constant actually varies with x, and it is given by this expression over here, which is k naught times 1 plus alpha x, right? Now you can think of this particular dielectric as a number of capacitors which are connected in series combination. Let's just put our focus at one small capacitor and let's see what is the value of the capacitance. So let's say I assume at a distance of x that we have a capacitor which is having a capacitance of DC. Now what is this value of DC going to be equal to? So we have the value of DC equals to A epsilon naught K naught, the whole thing is multiplied with 1 plus alpha x divided by dx, right? Now once we have got this, you think that if I have to find the value of C effective, because since all of them are connected in series, I'll get 1 by C effective is equal to summation of 1 by C. But in this case, since all of them are very, very small, infinitesimally small, we can take, or differential capacitors, we can say, I have to add them up, right? So simple summation is not going to work in this case. I need to, change the summation to the integration. So if I just do that, I'm going to integrate this with limits from 0 to d, right? So you have got this as an integration. So 0 to d dx divided by a epsilon naught k naught, and this is multiplied with 1 plus alpha x. Once you integrate, you're going to get ln of 1 plus alpha d divided by alpha a epsilon naught k naught. This is what you get. Now, once you have integrated this, you'll get the value of this entire set of capacitors which are connected in series, you can say. So you have got the C effective value, which is equal to, well, alpha a epsilon naught k naught divided by ln of 1 plus alpha d. But it's not the end over here, and that is why this is a difficult problem, because it has got multiple steps. At this point you might think, okay, I have arrived at the answer, but wait, you are not done yet. So now this term of ln 1 plus alpha d has to be, changed by using Taylor's theorem. So I use the Taylor's expansion, and you get the terms like alpha d minus alpha square d squared by 2 and so on, right? The higher order terms as such. And in the numerator you have got alpha a epsilon naught k naught, right? Now, if I just look at this expression, we get that, okay, if I take alpha as common, well, I can cancel off one of the alpha, right? So if I do that and simplify it further, well, alpha get cancelled out, and the next expression comes out neatly like a epsilon naught k naught divided by d minus alpha d squared plus 2. Now, if I just rearrange it and, well, reorder this, I'll get this further expression, which is a epsilon naught k naught. The whole thing is multiplied with 1 minus alpha d by 2, and this whole thing is raised to the power of minus 1 divided by d. And here we have an approximation, right? Binomial approximation. Since it is given in the problem that we have got alpha d much less than 1, so I can say that I can further simplify the whole thing, right? As a epsilon naught k naught times 1 plus alpha d by 2 divided by d, and that is the value of C effective. And once you see this, you get it even in the options as well, and this is the final expression that is required for the effective capacitance as far as this question goes, and that is the answer to this problem. Now let's move to this problem. Now this is a question from electrostats. Specifically, it's from electric field, one of my favorite topics as such. If I talk about this particular problem, well, you can term it as a medium level question. So let's look at the situation that is given in this problem. So now in this question, it is given that you have got two infinitely large plates and they are inclined at an angle of 30 degrees. Both of these plates are charged, and we have to find the value of electric field at this particular point. So if this angle is 30 degrees, that's the angle between the two plates, this total angle is going to be 150, which makes this angle equal to 75. If this angle is 75, of course, this angle is also going to be equal to 75, and that gives me this angle equal to 30 degrees, right? So this is what we have. Once we have got this angle, now we need to find the component of electric field along two directions as such. And if you look at the problem, it mentions x cap and y cap. Slightly peculiar, but yeah, it's just a different way to name things, right? So once we have got this, let's understand that we need to define our axis. So this will be y-axis, and anything along this direction we'll name it as y cap, and this is going to be our x-axis, and anything along this direction we are going to name it as x cap. This is why we have done this. Generally you use I cap and j cap, but this is just a notation that is matching with our option, so we are going to follow the same thing. Okay, now let's think about it. If I talk about the field in y direction, well, you have got, because of this particular plate, a field in positive y direction or y cap direction as such, and the value is E. Another field is at an angle of 30 degrees, just like this. and that is because of this plate, as you can see in the diagram, right? Now if I find a component, because the angle is 30 degrees, this comes out to be E cos 30 degrees, and perpendicular will be E sine 30 degrees. One more thing that you need to note is, while finding the angles, why I could do this and I could say directly that it is equal to 150 degrees as such, is because when you talk about the direction of electric field with reference to an infinitely charged plate, the direction of the electric field is going to be perpendicular to the surface. So this angle is 90 degrees. So there should not be any confusion. That is why I choose to tell you this, but this is something that you must remember as something very, very basic. Okay, so let's move on. So now all we have to do is express this value of electric field in terms of well, x cap and y cap. So let's do that. So let me write it as along x direction. Along x direction, what do we get? We have E net along x is going to be equal to, well, E sine 30, the value of sine 30 is 1 by 2. So we are going to get this as E by 2, but this is negative x, right? So we are going to get this as minus x cap. So let me put a minus over here and x cap. So this is what you get along x. Now let's talk about y. So along y direction, you have E net along y is going to be equal to, well, this is E minus E cos 30, and cos 30 is equal to root 3 by 2. So I can directly write it as E times 1 minus root 3 by 2 times y cap, right? This is what we get. Perfect. What about the E net vector? So E net vector is going to be equal to minus E by 2 x cap plus E times 1 minus root 3 by 2 y cap. That's what you have. Now let's just substitute the value of electric field. As you know, the value of electric field for an infinite plate is given by sigma by 2 epsilon naught, right? All you need to do is plug in the value of E in this expression right over here and then match it up with the correct option. So as far as this question goes, this is how you solve this problem on electric field. Now, if you look at this question, it was from electromagnetic waves, and if you ask me, this was one of the easiest question in this paper. Even our difficulty meter says so, right? So let's look at this problem. So in this problem, we have been given the value of the magnetic field and we have to find the expression of electric field as such. So B is generally expressed as B naught times sine omega t minus kx plus phi, right? And if I have to write the expression of E will be equal to E naught times sine omega t minus kx plus phi. Now if I think about the relation that exists between B naught and E naught, we have the ratio of E naught by B naught, that's equal to C, where C is the speed of light and the value of C is 3 into 10 to the power of 8 meters per second, right? So we have been given the value of B equal to, well, 3 into 10 to the power of minus 8 sine omega t minus kx plus phi. Now I have to find the value of E naught first of all. So E naught, if I just substitute the value of B naught in this expression right over here, right? In this expression, if I substitute, I get the value of E naught equals to 9. And then I can write the value of this electric field as E is equal to 9 sine omega t minus kx plus phi. And that will be the answer to this problem. Now let's look at the next question. Next question is from thermodynamics. Specifically, it's from work done during an adiabatic process. Okay, and if you talk about the difficulty level of this problem, I would say that it was a moderate in nature. So let's understand what is given in the question. So this question says that you have got 1 liter of an ideal gas, and this is expanding adiabatically under the conditions of STP, that is standard temperature and pressure, and the volume of this gas becomes 3 liters. We have to find in this question the value of work done as such. Okay, so let's understand that when it is told that initial condition was STP, so I can write P1, the value of initial pressure, as 1 atm. Whenever you get the condition like STP, you understand that the pressure is 1 atmospheric pressure and you have the temperature at 0 degrees Celsius or 273 Kelvin. Okay, so I'll get temperature, that is T1, also equal to 273 Kelvin, right? Now we know the equation of adiabatic process, that is PV raised to the power gamma is equal to constant, right? So I can write P1 V1 raised to the power gamma is equal to P2 V2 raised to the power gamma, right? We have the value of V1 and V2. We know the value of P1. We need the value of P2. So P2 is going to be equal to P1, and we'll have V1 by V2 raised to the power gamma, right? We know the value of P1 is equal to 1 atmospheric pressure, so let me just plug it as 1, and V1 by V2 will be 1 by 3, and this will be raised to the power of 1 by 1.4 because that's the value of gamma. Now you have been provided with this value of 3 to the power of 1 by 4 is supposed to be taken equal to 4.65, and there is a specific reason for that. The reason being that you need that value in this expression, so you get the value of P2 equals to, well, 1 by 4.65, right? Now once you have reached up to this point, you have to calculate the value of work done. And how will you calculate the value of work done? So for work done, you have this formula, that is P1 V1 minus P2 V2 divided by gamma minus 1. That's the work done for an adiabatic process. Let me just write it down. Work done for an adiabatic process is P1 V1 minus P2 V2 divided by gamma minus 1. And this was the sole purpose why we found out the value of P2. You have got all these values, right? P1 V1 P2 V2, and once you plug them in, you're going to get the final value as 89.87 joules, in terms of joules, of course. So 89.87 is what you get as an answer. But well, sometimes it happens in the options, you don't get the exact value. So you must choose the option which is closest to your answer. So as far as this question goes, the option which is closest to 89.87 is the correct answer to this problem. This question is from electromagnetism, specifically from the concept of magnetic flux, and this is more towards the medium level. This was a conceptual question, one of the rare questions that was asked. Just conceptual understanding of the topic is required and you will be able to answer it. Okay, so this was one of those questions which you could have answered very quickly. So now let's look at the problem. So it says that you have a loop carrying some current and an infinite plane is placed over this ring as such, or loop. Now we have to talk about two regions, and in these two regions we have to talk specifically about the value of magnetic flux. One is the inner region of this ring and another is the outer region, this one. So how will the magnetic field lines look like? So magnetic field lines form a closed loop. So this is how they'll be looking like, and it's just I'm showing you the bottom of it. So they always form closed loops, right? Now if I say that phi I is the magnetic flux inside and phi O is the magnetic flux outside, and there will be many more. It will be like, how I remember it is like bangles. Okay, so you have a ring and you think of putting a lot of bangles over there. That's how the magnetic field lines actually look like. Now, one thing is sure, whatever number of field lines are inside are also outside. So the number is same. So I can write phi I equals to phi O. But here is the problem. Most of the students actually make this mistake. You don't care about the direction. In this case, if you notice, the direction of phi I is opposite to that of the direction of phi O. So we need to include a minus sign over it. So phi I is equal to minus of phi O, and that is the answer to this problem. Now this question is an integer type of problem, and it is from work power energy. And if I talk about the concept that is involved, it is from conservation of energy as such. Well, this I rate it as an easy problem, right? So let's look at the question. So in this question, we have been given with a mass, and it is located at this point A, and it follows this path as you can see in the figure. Mass is 1 kilogram, height of point A is 2 meter, and the maximum height it reaches once it falls down this path as such is given as 1 meter. Now, this is how this mass is going to fall, right? And we have to find the value of kinetic energy at point P. Now, this is a pretty simple question. If I take this as my datum level, I can say that the potential energy at point A is equal to the potential energy plus kinetic energy at point P, right? That's very simple from law of conservation of energy. So straight away we'll apply this law. At point A, you know that this ball was at rest, so it only has a potential energy when it was at point A. Once it starts moving, of course, it will get kinetic energy. So I can write at point A, M, G and H is given as 2 meters. So 2 is equal to the potential energy at point P, which is M, G, and the height is 1 meter, so 1, plus the kinetic energy at point P. So kinetic energy at point P, I'm not writing it as half mv square because we don't have to find the velocity, we just have to find the value of kinetic energy. So what do you get? Kinetic energy at P is equal to mg, and let's just plug in the value. So mass is given as 1 kilogram, acceleration due to gravity is 10 meters per second square. So well, you get these many joules. So 10 joules is the value of kinetic energy, and that is the answer to this question. Now this is an integer type of problem again, and this question is from mechanical properties of solid, specifically from volumetric expansion. And well, I'll say that this is a moderate type of question. So let's look at what is given in the problem. So in this question, you have a metal cube, okay? And the coefficient of linear expansion along x-axis, y-axis and z-axis is given. And it's told that the coefficient of volume expansion is expressed as n into 10 to the power of -6 per degree Celsius, right? We have to find the value of n. So if I represent this coefficient of volumetric expansion as v, let's say v, the formula is alpha x plus alpha y plus alpha z, right? So this is the formula. So if I just plug them in, and if you notice that my final expression is n into 10 to the power of -6, so I'll convert everything in 10 to the power of -6 so that it's easier for me to compare. So I can write 5 into 10 to the power of -5, which is alpha x, as 50 into 10 to the power of -6, plus we have 5 into 10 to the power of -6 plus again 5 into 10 to the power of -6. Well, this gives me a value of 50 plus 10, that's 60 into 10 to the power of -6. And if you compare it with the expression which is given in the problem, well, n comes out to be 60. So the value of n is 60, and that is the answer to this question. this integer type of question was from thermodynamics, specifically from Carnot cycle or Carnot engine, right? So if you ask me, this question was of easy type because this was directly based on the formula. So in this question, it is told that a heat engine, a reversible heat engine, operates between two temperature reservoirs, thermal reservoirs as such. So the higher temperature of the source is at 900 Kelvin and the sink is at 300 Kelvin. And we have to find the value of heat rejected to the sink. So let me first draw the block diagram. So the first block will be the thermal reservoir, which is source, and the temperature is 900 Kelvin, right? And then you have a heat engine, and then you'll have the sink, and this temperature is 300 Kelvin. So how this heat engine works is, it is going to take some heat from the source, let's say Q1, it's going to do some work, W, and then it is going to reject some heat. It has to, by a second law of thermodynamics, it has to reject some heat to the sink, right? And we have to find this value of Q2. Now, since this is a Carnot engine and reversible one, I know the formula of efficiency. So efficiency is equal to, well, work done divided by heat supplied, which in this case is Q1. This is also equal to 1 minus T2 by T1, where T2 is the temperature of the sink and T1 is the temperature of the source. So if I plug in that value, I am going to get 1 minus 300 by 900, and this cancels out with 1 by 3. Well, okay. So what do we get? We have W by Q1 is equal to 2 by 3. So from here, I can write Q1 is equal to 3 by 2 times of W. Right? Now, once we have got this, let's apply the conservation of energy principle. So you know that the net heat supplied is Q1, some of it is used to do some work and the rest is rejected. So I can write, well, Q1 is equal to W plus Q2. We have to find Q2, so Q2 will be equal to Q1 minus W, right? And Q1 value we have over here, so I can just replace it. So Q2 is equal to 3 by 2 times of W minus W, that gives you, well, W by 2, and the value of W is 1200 joules. So if you divide it by 2, you get the value of Q2 equals to 600 joules. So 600 joules is the correct answer to this problem. So this is the integer type of problem from the topic of electromagnetic induction or EMI, and specifically it is from magnetic flux, and this is, I would say, a easy type of a question. So in this question, you have been given with certain coordinates as such. So we are going to define our coordinate as x cap, I cap and j cap. These are the unit vectors along x, y and z. And once you have got these coordinates, so you need to find the effective flux through the area by, of course, joining these points. And once you join them, this is how the area looks like. Now we have to find the flux. So flux is equal to, let's say net, is equal to B vector dot A vector, right? So it's a dot product between the magnetic field and the area vector, right? So let's write first of all the magnetic field vector. So magnetic field vector in this case is 3I cap plus 4k cap. This is what you have as the magnetic field vector. Now let's write the area vector. For this surface, you know the area vector will be in this direction and the magnitude will be, if you see the coordinate, that will be 5 times 5, and that's 25 I cap, right? So area vector is 25 I cap, and along this also you'll have area vector like this, and the magnitude is again going to be equal to 25 and the direction is still k cap, so you have 25 k cap, right? Let's just find the dot product. So I goes with I and k with k, so you get phi equals to 25 times of 3, that's 75 plus 100, right? So this is equal to 175 Weber, and that's the answer to this question. Now this question is from dual nature of matter, and specifically it is from photoelectric effect. And if I have to rate this problem, I would say that this is of a medium level question. So now let's look at this problem. So in this problem, we have been told that you have a metallic surface and then some light is incident on it. And you have been given the value of work function, area, and the intensity of the radiation as well. What we have to find out is once this light is incident on the surface, then electrons are going to be ejected out, right? All these are photoelectrons. How many such photoelectrons are ejected out as such? And it is expressed as 10 to the power of x, and we have to find this value of x, right? So first of all, let's first check whether a photoelectric effect happens or doesn't happen, because if the value of energy is less than the work function, then there is no chance that this photoelectric effect can occur, right? So energy of a photon is given by hc by lambda, and hc value is 1240 divided by lambda 310. Well, you can use this formula only when the value of wavelength is in terms of nanometers. This comes out to be equal to 4 electron volts, right? Let's say there are n number of photons. So if there are n number of photons, I can write the total energy in terms of joule as n into 4 times 1.6 into 10 to the power of minus 19, right? And this is going to be equal to intensity times area. Why? Because intensity is energy per unit area. So this is going to be equal to 6.4 into 10 to the power of minus 5. From here, you're going to get the value of n is equal to 10 to the power of 14. So this is the total number of a photoelectron. But you must notice that every 1000 photons, sorry, this is the total number of photons, not the photoelectrons. So you must notice that we have got the total number of photons as 10 to the power of 14, right? And for every 1000 photons, you get one photoelectron. So how many electrons will be there? So I need to divide this by 10 to the power of 3. So the value comes out to be equal to, well, not here. The value comes out to be equal to 10 to the power of 11. And as asked in the problem, we have to express as 10 to the power of x, and we have to find the value of x, right? So clearly the value of x is equal to 11, and that is the answer to this question. This was a question from ray optics, and the topic or the concept that was involved was from compound microscope. And if you ask me the difficulty level of this problem, well, it was a moderate type of question. So in this question, we have been given the value of magnification, we had the value of tube length, and we had the value of focal length as well. Now, why I have kept it in the moderate category? The reason is that you need to remember the formula. The formula of a relation between the focal length of objective lens, the eyepiece, and magnification can be slightly tricky to remember as such. But this question, as far as this question goes, well, this was just substituting the values and getting the answer. We had to find, however, in this problem, the value of focal length of the eyepiece. So let's look at this formula. So m is equal to L by FO, where L is the length and FO is the focal length of the objective lens, and the whole thing is multiplied by 1 plus D by FE, where D is the least distance of distinct vision, which we should take it as 25 centimeters. Now, since all the values are given to us, all we need is to plug in these values and solve for FE, because the FE is the focal length of the eyepiece, and that is what is required in this problem. Now, if you notice, you have got two units of length in this, right? So one is in centimeters and one is in millimeters. But if you look at the options, all the options are in millimeters. So a wise thing to do would be to convert everything in terms of millimeters and then plug it in this formula. So let's do that. So magnification is 375, which is going to be equal to L is 150 already in mm. So I don't need to worry about it, divided by the focal length of the objective lens, that is 5 centimeter in terms of millimeter, it is going to be 50, and then 1 plus d, which is the least distance of distinct vision, we should take it as 25 centimeters, but in millimeters it will be 250 divided by FE, focal length of the eyepiece. So focal length of the eyepiece is what we have to figure out, right? So I can cancel this off. Well, this goes 3 times and this will go 125 times, right? We end up getting the value of FE equals to 250 by 124, right, in terms of mm, and this approximately comes out to be 2 millimeters, right? And that is the answer to this problem. Now that we have solved all the questions from this paper, you must remember one thing, that all these questions were memory based. So when the actual questions come on the website of NTA, they might be slightly different, but however the concepts remain the same. So that's all for today's session. Keep learning.
For more videos and live lectures on the JEE, click on the subscribe button now.